Hi there. I've decided to proceed with the course using the OpenStax textbook. You'll notice that the following video makes reference to Chapter 4, but you need to realize that when I first recorded those videos, we were using an actual physical textbook. The videos are still good. The content is exactly what you need to learn, but I want you to refer to the Adams First 2nd edition OpenStax textbook. And going forward, I'm going to stick with this textbook. That should make things a little less confusing for everybody, and I hope you enjoy this book. I think it's very well done. Hi there. I decided to do a few shorter videos for Chapter 4 because it's pretty easy to break this one up. So the first part of the chapter goes into the development of atomic theory, which is really important for us to understand. First thing, you have to be able to define atom and element. And so the atom is the smallest identifiable unit of an element. And so that's kind of, the words are kind of confusing here. What we mean by identifiable is that it'll have all of the chemical and physical properties of that particular element. So for example, if you're talking about gold, then you are going to have an atom of gold. It will have all of the properties that you would expect if you had an entire brick of gold. An element is defined as a substance that cannot be broken down into simpler substances. Now, of course, elements are made up of atoms. Sometimes they're made up of molecules, but what we mean is if you compare, for example, to the compound water, this can be broken down into hydrogen and oxygen. So that's what we mean by simpler substances. All right, so now the idea of the atom was first proposed about 2,500 years ago, and Democritus was involved in this, and also another philosopher, a Greek philosopher, and his name was Leucippus. And then you might wonder why it took so long for the idea of the atom to come back again. It took until about 2,000 years after that before people started talking about the idea of the atom. And the reason is because the well-respected philosopher of the day was Aristotle, and you may have heard of him. He had a lot of influence, and so he disagreed with the idea that these philosophers came up with. He believed that everything was made of earth, fire, water, and air. And so when Democritus and Leucippus came up with this idea of the atom, that was a tiny indestructible particle, he talked it down, and the idea didn't arise again until late in the 18th century and into the 19th century. There's a little typo there, so let's just scratch out that S. So in 1808, a scientist named John Dalton, came up with his theory, and much of it is still used today. These are the three premises of his theory, and they are still accepted. So the idea of indestructible particles, the idea that all atoms of the same element have the same mass and other properties that distinguish them from atoms of other elements, so that's their chemical and physical properties. And then the idea that they combine in simple whole number ratios to form compounds. So if you look at H2O, for example, it's a 2-to-1 ratio of hydrogen to oxygen. We don't write it as H1O 0.5 because we can't have half of an atom. So that's what we mean by simple whole number ratios. Okay, so that's the beginning of atomic theory. In the next little video, I want to talk about the development of the nuclear atom, which is how we understand it today.